Dear students, today in this video we are going to discuss on the symbols we are going to use in the concept electricity. I know electricity has been there since your 8th standards. So, this video is applicable for all the students from 8th standard till 10th standard. So, let us understand on some of the concepts, some of the symbols that we usually use when you are writing electric diagrams or discussing on few for topics like that. So, my topic for today would be, as you know, it is nothing but symbols used in electricity, right? Okay, having said, I'll do one thing. Let me take you all for a very simple electric circuit diagram. So, we have noted that this line is quite longer compared to its other line. And then what else have we noted? There is one closed circuit like this. So, here what do we say for this? Here we say this is cell, and we said this side is plus and this side is minus, and they both are getting connected through a wire. So, whatever this line is there, it is nothing but the wire. Now, on the plus side when we said it is, we mentioned it as anode. The electrode name is called anode, and on the minus side we said it as cathode. We said it as cathode. Any idea as to why we said this side as anode and the other side as cathode? Anode, when we say it as plus, it has excess of electrons. When it has something in excess, always it is plus like that. So, it is ready to give the electrons, meaning to say this person who is called anode, he is ready to donate the electrons. And the other person, obviously, because it is a closed circuit diagram, anything has to be only within that. So, somewhere the electrons came out, somewhere it has to go and get inside, it has to lock inside, where else it has to be on the cathode side. So, another way of remembering, A is plus, C is minus, anode plus, cathode minus. Okay. And in the meantime, when you looked out for this diagram, you could understand there was another thing called another thing that we saw was on the what is that the bulb. Yes, it was the bulb which was there. Let me just draw the bulb also. I am just pulling the cursors this side. Yes, here goes the bulb. Obviously, yes, there should be a little disconnection here. Yes, here is my wire. I'll write the bulb here. Okay. So, if I say these are the two ends that we saw in the bulb, the incandescent bulb that we can think of, or any LED bulbs, what we use at home. Okay, right. So, there is one filament attached here, and the filament goes like this. It's a circular ring, I can say, which is curled actually. Okay. So, here the bulb get attached to the bulged end in the bulged ends are attached to the wire, and this is how our bulb looks like. Of course, the filament and the bulb are not connected. The glass one, the outer glass and the inside filament, they are not touched. If they are touched, the bulb will not work. Next, so here what does this mean? See, there is a passage of electrons. The electrons came, they were coming, they came towards here. Let me write the direction also. So, as we are doing it, the electrons went inside here. So, they went inside here, and they made the filament to glow here. Then the electrons are coming out from here, right? They moved from here, and they went back to cathode. They made the filament to glow. Why did actually the electrons make the filament to glow? So, let us forget about this concept of electrons or energy that we have not seen. We will just imagine ourselves being in a strong wind. Obviously, there is a shake. When we are standing, will not be firm when we are standing. Will not be sitting, standing straight and firm. When we are standing, when there is a huge, big wind, we will shake. We'll move here and there, right? Because that energy, when along with the wind, was more compared to what we are there, and it could shake us. That energy is bigger than our standing energy. And it's similarly here, the energy what it is coming out, the power what it is coming out from in this circuit, that is specially from the anode, it is making that filament to glow. That filament is getting charged. And which is that filament which can get charged? That is nothing but any conducting material. Then what is that kind of material? We can think of copper, we can think of brass, or we can think of many metals which are the conductors, right? That we have seen in our earlier classes, and we have seen in our general bulbs also, which we use at home. Okay, so it started conducting. It started conducting in the sense to say what? It started glowing from within, or it started taking in that energy, and that energy was passed on to the other side also. Okay, if that is the case, fine, this is a small bulb and this is a small cell, it worked. What do I do when I have to connect a big bulb, let's say some 1000 volts bulb, 100 watts bulb, something like that? What do I do? Now obviously, instead of one cell, shall I give another cell? This is one cell. Let me just erase. If I say this as one cell, now I am giving you another cell. Can I connect by a wire? If I want little more, I am connecting another wire, another cell, and I am connecting everything by a wire, and I have one bulb and I am making it to glow, right? So here, when we said about cells, you have one different meaning here. What is this cell actually? Are they or not the cells that we buy from the general stores, that we usually use in our TV remotes, or in our watches, or in our torches? Yes, they are the ones. Everyday battery, there are many companies like that, right? This is that cell. One will be having positive end, another will be having negative end. The one which is having the positive end is your anode, the one which is having the negative end is your cathode. So when I want to have, probably you would have observed this in the torches, one battery wouldn't be sufficient, we would be using many more, and the positive end and the negative end, then the next would be like the positive and the negative like this, they should be touched. And the same way, look here, it is a positive end, it is a negative end, here is a positive end, this is a negative end. So this is how we are connecting the multiple cells, 2, 3 and so on, and we are using a different item for glow. Alright. Now, if that is the case, we understood that the current is flowing inside the circuit diagram, and how we made sure it is by glowing the bulb. The bulb, when it started glowing, we got to know that yes, the current is proper and it's glowing. When it is kind of blinking here, there, inking here, there, still the current is flowing, but that's not sufficient for the bulb to glow, or there is some leakage or something like that. Okay. Now, so one thing we understood is on this simple circuit diagram, we understood on the bulb. Now, can I replace the bulb with something else? Isn't it? See, now we have made the bulb to glow. So, similarly, instead of the bulb, I will do one thing. Let me take a water heater. So, for that, I will do one thing. I will just make this as an open end and put it inside water, or let me draw it. Let me draw it not here. I'll draw this to be on the downside. Here, what I do, okay. So let me take eraser and I will write one wire. The open ends of this wire, I will put it in a beaker or a big jar or anything which is having water in it. These ends are touching the water. They are not completely immersed, of course they are submerged, I can say. It is there, right? This is water which is there, and we got to know that the water inside this starts boiling, right? So, how do I give you the examples? Why not the water heater? So, you have two coils inside the water heater. The same way, yeah, sorry, this has to come like this. So, these are the wires that are open and it's kept inside. Instead of that, of course, you can make it as two electrodes also. You can make them as two electrodes also. Of course, it shouldn't be touching the container. Let me remove the container here. It shouldn't be touching the container. It should be such big enough, and water is there everywhere. Got it? So, these are the two electrodes. The one is on positive side, electrodes, and other is on negative side. This is water which is boiling. So, now we got to know there is another usage by the circuit diagram which is boiling the water. So, here we have used it as a boiler rather, right. So, initially the first one what we did was by glowing the bulb. Maybe you have taken the diagram there, and now it is boiling the water. Okay. Now, are there any other usages that we have seen in our books? Do we know anything more than this? Yes, there are many more usages of this simple circuit diagram that we have seen in our books also, we have read also. Now, why don't I just do one thing? Why don't I connect one magnetic compass? Yes, let me connect a magnetic compass. As we did, I'll replace the water container. Now, I am connecting the ends here to the magnetic compass. North side, south side. Here what I do, I will roll it over. I can roll it over, or I am just connecting. So, here fully the wire, the conducting wire is rolled over this and it's got attached. So, the compass starts shaking and it starts showing different directions. It means compass is working through the electricity. Now, what happens? How do I get to know that there is so much of voltage in this electricity, in this current which is passing? There is so much of current and stuff like that. Now, I will do one thing. Let me connect a voltmeter. This is called a voltmeter. Done? Okay. If that is the case, if I can connect the voltmeter, can I connect a ammeter? What for is ammeter? It is again to see the current which is there, the number of electrons which are there. We will discuss more on what is how do we measure the current, how do we measure voltage, the voltage difference or the potential difference and so on. For now, let us understand what are the different tools or different instruments that we are connecting. Initially what we connected, it was a bulb. Then we just removed it, we removed the ends, we broke the ends of the wire, we put them inside the beaker which was having water inside it, and the water started boiling. Second one, in the same way we connected a compass also for the magnetic current electric current to get changed to magnetic field. Then the fourth one was connecting the voltmeter. Fifth one is ammeter. And then if that is the case, why not a resistor? Right? We will understand what is this resistor, why should I do, and what is its need and all. The resistor looks very simple. This is just this way. This is a resistor. right? So in all these different ways, we started connecting our circuit diagram to different instruments. Now if I want, as I said earlier, how do we connect the multiple cells? Using a wire to connect them. So same way, how do we represent them was a question, and now what we did was we connected them through a wire. Now I do one thing, let me just erase this. Okay, it went off, and here I will connect a bigger another cell, I will connect another cell, I will connect another cell. If you observed, this was positive and this was negative side, and this is again positive side, negative side, positive side, negative side, positive, negative. We connected cell number 1, sorry, here is cell number 1, this goes as cell number 2, number 3 and number 4. So we connected 4 cells here. We can connect multiples like this, multiple cells like this. Got it? So now we understood multiple cells connection also. We understood different instruments that we can use. And next comes another important one. When we are talking about these cells, there comes an important topic called DC and AC. What is this direct current? What is this alternating current? And how do we represent them in symbols? Our topic, remember, is to understand about the symbols. So how do we do that? Now, DC, direct current. It is the one. Have you any time seen like when you are connecting the bulb? Have you any time seen the bulb starts glowing very bright, again it goes off, very bright, goes off, it starts blinking. Every time it does so? No, only when there is no power inside it, and after it's used for a long time, then only the power goes off, and then only we can see some small blinking, feeble blinking, and it just goes off, the cells gets dried. So here such kind of cells are called direct current, or these cells which we use for our remotes, for our watches, they are called dry cells, right? Like this, under the direct current, we have many other different types of cells. We'll discuss about them later. This topic is a very general topic which is pertaining 8th standard, 9th standard and 10th standard. So why the detailed topics we can't speak in this video, right? So as I talked about the direct current DC, now I need to talk on AC, or something called alternating current, which keeps alternating with its what? Frequency. How do I represent? Like this. Meaning, I will do like this, I will write like this, and this is called the alternate current. Okay, so having said about these two, next let me take you for the switches. Open switch, closed. Okay, whenever I am writing first here, it will be open. It is a single pin switch. Let me take this as an example. If it is not put inside the socket, then it is single. It is open. When it is put inside, it is closed. Next, I have the tap switch. It looks like this. It's open, looks like this. Whereas, the same way, when the circuit has to be closed, it has to get attached. So, it looks like this. This is an example of the switch being on and off. We have that at our ohms. Next, we have another 2-pin switch. Here, in case of the 2-pin switch, this will be its open end when it is not on. When we are connecting the switch, it is on. This is the one. Okay, so as we are moving on, when we understand about this video and when we make notes of this video, it is very easy for us to remember this and carry this further in our discussion. So that's why this video is made, and please, I request you all to take down the notes and keep this as a reference. Thank you.